everyone, welcome to my channel. In this video, I'll be showing you how to solve the problem number of islands. So firstly, what is an island? An island is an area of land that is surrounded by water on all sides. So with that premise, let us try to understand the problem statement. So we're given a 2D matrix consisting of ones and zeros. A 1 represents land and a 0 represents water. So a group of ones that are connected horizontally or vertically form an island. So here, these set of ones, these 4 ones together form an island. Anything beyond this matrix on either side is water. So these 4 ones form an island. These 3 ones form another island, and this one alone itself is another island. So the total number of islands is 3, and this is what we have to find. Now let's look at another example here. So this whole set of ones here form one island, and the rest is water. So the total number of islands here is equal to 1. So how can we solve this problem? We can solve this problem using DFS and backtracking. This same technique is used to solve another problem called word search. So I've solved that problem, and the link to that problem is present in the description below. Now let's see how this works here. The idea here is pretty simple. We iterate through every element of the matrix starting in the first element. Whenever we see a 1, that is whenever we encounter a land, we increment the number of islands by 1. Now in order to find the adjacent lands that are part of the same island, we do a depth first search starting from that element in all 4 directions, that is left, right, up and down. And now in order to keep track of the elements that are already visited, we can either change the value of the cell to 0, or we can use the 2D Boolean matrix to keep track of the visited elements. So here we shall change the value to 0, and now let's see the visualization. Okay, now let's start with the first element. Here the value is equal to 1. That means we have found a land. So let's increment the number of islands by 1. Now, since we have visited this land, let's mark it saying that we have visited this land. I'll mark it as 0. Now let's explore the neighbors of this land that are part of the same island. So for that, we'll do a depth first search in all 4 directions. So let's start with the left neighbor first. Here this value is invalid, so we come back in the recursion. Now we are back here. Now let's explore the right neighbor of this cell. So this value is equal to 1. So this is part of the same land, island. So let's mark it as visited. Now let's explore the neighbors of this land here. So that is the left neighbor first. Now this value is 0, so we come back in the recursion. Now let's explore the right neighbor of this cell here. This value is 0 here, so we again come back in the recursion. Now let's explore the top neighbor here. This row is invalid, so we come back in the recursion. Now let's explore the bottom neighbor, the down one. So this value is equal to 1. That means we have found another land that is part of the same island. So let's mark it as visited. Now let's explore the neighbors of this land here. So let's explore the left neighbor. This value is 1. So again, let's mark this value as visited. Now let's explore the neighbors of this land. You get the idea, right? So this column is invalid, so we come back in the recursion. Now we have explored the left neighbor of this cell, so let's explore the right neighbor of this cell. So this value is 0, so we can come back in the recursion. We have explored the left and the right neighbors. Now let's explore the top neighbor. So this value is 0, so we can come back in the recursion. we have explored the left, right and the top neighbors. Now let's explore the bottom neighbor of this cell. This value is 0, so we can come back in the recursion. So we have explored the left, right, top and the bottom neighbors. Now we can come back in this recursive call here, the first recursive call that made the call to this cell here. So we'll come back. Now for this cell here we have explored the left neighbor, so we'll explore the right neighbor for this cell. This value is 0, so we can come back in the recursion. Now we have explored the left and the right neighbors for this cell, so we'll explore the top neighbor now. So this value is 0, so we can come back in the recursion again. Now let's explore the bottom neighbor. This value is 0, so we can come back in the recursion. Now we have explored the left, right, top and the bottom neighbors for this cell. Now let's find so this is the call that made the recursive call to this cell here. So let's go back in this recursive call. So for this cell here we have explored the left, right, top and the bottom neighbors, and the recursive call to this cell here was made by this function. So let's go back in the recursion. Now we are back to the first cell. So basically all these 4 cells were part of the same island. So we have made a recursive call, that is depth first search, starting from this cell, and found out that all of these are part of the same island. Now we have finished the first element. Now we have to explore the next element here. So let me clean this recursive calls here first. Okay, now we are done with this element. Now let's explore the other elements. So we'll go to column 1. So this is row 0 and column 1. This value is equal to 0. This is water, so we don't need to do anything. So we'll iterate to the next element. Column is equal to 2. Now this value is 0. So again we don't need to do anything. We can continue to move to the next element. Now all of these values here are 0. So we can skip them and directly go to this element here. And column is it's the same column. Okay, now this value is equal to 1. That means we have found another island. So let's increment the number of islands by 1. So this is equal to 2. Now let's mark this cell as visited and explore the neighbors of this cell. So first let's visit the left neighbor. So this value is equal to 0. So we don't need anything. We'll come back in the recursion. We have explored the left neighbor. Now let's visit the right neighbor. This value is equal to 1. That means we have found a land that is part of the same island. So we'll mark this as visited. Now let's explore the neighbors of this land here. So for that we'll first call the left neighbor. So this value is 0. So we come back in the recursion. So we have visited the left neighbor for this cell. Now let's visit the right neighbor. So this value is 0. So we come back in the recursion. Now we've visited the left and the right neighbors. Now let's visit the top neighbor. This value is again 0. So we come back in the recursion. Similarly, this value is 0 here when we visit the bottom neighbor. So this is 0. So we come back in the recursion. Now we have explored the left, right, top and the bottom neighbors for this cell. Now let's go back to the recursive call that made the call to this cell. So that is this call here. So we'll go back here. Now we have explored the left and the right neighbors. Now let's explore the top neighbor to this cell here. So this value is 0. So we can come back in the recursion. Now let's visit the bottom neighbor to this cell. So this value is 1, so let's mark it as visited. Now let's explore the neighbors of this cell here. Now you know that these values are 0, so I'm not going to trace it again. So let's go back in the recursion. So we have explored the left, right, top and the bottom neighbors for this cell. Now let's continue to explore the other elements in this matrix. So let me clean this up first. Okay, now let's continue to explore the other elements. Here all of these values are 0, that means they are water, so we don't need to do anything. So let's move to the last element here, that is column 5 and row 3. Okay, this value here is equal to 1, that means we have found another island. So let's increment the number of islands by 1. Now let's explore the neighbors of this island here, or the neighbors of this element here. So first let's visit the left neighbor. This value here is 0, that means it's water, so we can come back in the recursion. Let's visit the right neighbor. This is an invalid value, so we can come back in the recursion. Let's visit the top neighbor. This value is 0, so we can come back in the recursion. Let's visit the bottom neighbor. This value is again invalid, so we can, or this cell is invalid, so we can come back in the recursion. Now we have explored all the elements in this matrix, and we have found out that the total number of islands is equal to 3. So this is the expected output. Now let's look at the code.
Okay, I hope the visualization helped to understand the problem. Now let's take a look at the code here. It's actually very simple. Here we have a class called number of islands, and inside the class we have a private variable called number of islands. This is what we have to calculate, and a function called DFS. Let's come back to this. First, let's take a look at the main function here. Here I'm creating an object of this class number of islands. We have the input matrix. I am just making a check if the matrix is null. This is for the edge cases. Now we iterate through every element in this matrix, starting with the first element. Now, whenever we encounter a land, that is whenever the value here is equal to 1, we just increment the number of islands and then check for the neighboring lands that are part of the same island. So for that, we trigger this DFS function. So let's now look at the DFS function here. So we are here. So here we are making a basic check that if the row is less than 0, that is, we are basically making a check for the out of bounds. So a row is less than 0 or row is greater than matrix.length. Similarly with the column, then we just simply return because this is an invalid cell. Now, if the cell value is 0, that means if we are visiting water or if the value was changed in the previous call, then we simply return. Now, if the value is equal to 1, then we just modify this value to 0 so that we are making sure that this cell is visited. We are marking it as visited. And now we trigger a DFS in all 4 directions. So that is left column, column -1, right column, top row and bottom row. So as simple as that. Now let me just run this example here. So the expected number of islands is equal to 3. Let me make a small change. So here let me make this as 1. Now these 4 form one island and these 5 together form another island. So let's run this example. So we get the number of islands as 2. So I hope this helped to understand the problem. If you think you've learned something new, please hit the like button. Do subscribe for more videos. Thank you.